What is up, car and tech fans? Welcome back to another garage tinkering video. Last week was the first week where I missed a video because I've been really ill for the last couple of weeks and I'm still right at the end of it. So if I sound a little bit hoarse or haggard, that's why. I'm still getting over it. And it's why we're going to keep things a little bit simple today and not launch into anything too complex. But we're going to talk about what I feel are the 6 key areas and key skills that you need to learn if you want to become a really good digital dashboard gauge designer. And it isn't just for creating stuff for cars. It might be, a thing that you want to produce that goes on the wall in your house that controls something to do with, I don't know, Home Assistant. But you want to productionize it in a way that makes it professional and well finished and feels polished. And how can you ensure you can do that from the physical layer all the way through to the... At the end of this video, we'll look at my skill set and the hexagon of skills and see where I need to increase, because I don't pretend to be a master of all of these subjects. Some of them I know very, very well, some of them less so, but we'll get to that at the end, and then you can see where you sit and we'll compare them, and then we'll see where everybody sits and which areas everybody needs to increase the most. So from my perspective, these are the 6 things I feel that you need to master. And we'll kick it off with the one that I think is overlooked the most, and that's perhaps the most important. And it comes at the very start of the process, but also at the very end of the process, and it's the user experience design. Now, we don't want to confuse user experience design with graphic design or visual design. User experience design is more about defining the set of parameters that the thing that you're creating is judged by in order to decide whether or not it is being successful in its purpose. It's often the thing that, when changed, jars the most. So, for example, the amount of times we've seen that Facebook has updated its UI, and people go, "Oh, I hate the new Facebook UI," but what they really hate is the new user experience flow. Maybe something changes in the way that you interact with it or the way that you put information in, and it breaks the flow at which you usually enter and exit, like the process of utilizing and using Facebook. So that's the thing that jars and people don't like. When it comes to digital dashboard design, it's ensuring that the gauges themselves are functional and intuitive, and that they relay on the correct information in a timely manner without ever being distracting or over the top. The reason I like to put this first is, for me, when I'm designing a new digital dashboard, it's the first thing that I like to think about. How am I going to display specific bits of information over sometimes several screens and ensure that the information on each one of those things is purposeful? It might be things like splitting up information into primary, secondary, and tertiary based on its importance. For example, primary information could be your speed or your RPM, things that you need to keep a constant eye on. Whereas secondary information is stuff that's more like fuel level or oil pressure, things that you need to be aware of changing, but don't necessarily need to draw all of your attention all of the time. Whereas tertiary things are things that just like tick along in the background, like I don't know, your trip counter, something that you can look at and you can say, okay, I've done 112 miles since I've reset the trip counter, but it's not, generally speaking, a really important piece of information. And interestingly, user experience design is one of the things that is subject to change over time, as well as you actually utilize the things that you've created. A really different example is that after I went to Caffeine and Machine for the first time and saw an "I love you, man" speech, I bought one of the "I love you, man" key rings, and it hangs on my mirror next to me in the middle of my car. And for the first couple of times I drove the car, I could see this little thing swinging, and it was just a little distraction. But now that it's been in the car a year, I don't notice it. So over time, my interaction with that little thing has changed. So the user experience has altered because I have altered. So as much as we can plan and try and design things that have good user-centered design approaches for them, there is a good chance that things are going to change over time, and our requirements are going to change as we change. which is why UX design is first and really last part of the process. We think about it beforehand, but then at the end, we're constantly testing and we're constantly feeding back into this loop of creation in order to take the changes in us and the changes in our requirements and feed them back into the process. It's not something we've looked at a lot yet in this channel, or how to do and apply, but it's something we're going to be creating some videos on this year, because I do have an extensive history in UX design, and it's something I think people overlook a lot, and it is some information I would like to get from my brain into your brains. So we'll do some stuff on that later in the year. UX design flows really nicely into the thing you're probably going to do second, just the standard user interface design. How does the thing actually look? Less about how it's laid out, but what colors are you going to use? What fonts are you going to use? We've all seen screenshots of people who use like crazy fonts on the phone, and you sit and you just go, and in the same way, I've sat in different cars that have got, entirely blue dashboards, or some that have entirely white or entirely amber, and it completely changes the way that the car feels to be inside, especially at night. So what kind of ambiance are you trying to create inside your car? Is it trying to be energetic and uplifting? Is it trying to be kind of like just chill and not somber, but like muted? How are you utilizing color theory? We all know that generally speaking, green means good, amber means warning, red means bad. So do you utilize that in your designs in some way? Are you trying to make your gauges and your dashboard feel cohesive with everything that exists currently in the car? Or are you ripping everything out and starting again? Based on the answers, that could really depend on how you actually go ahead and design your gauges. If you're doing everything, you're pulling out all of the displays and designing everything from scratch, it doesn't really matter too much about cohesion. But if you're going to try and say, change your driver's information cluster in front of you, but the rest of them are all staying OEM, maybe you want to make sure that it feels cohesive, that the fonts are similar, that the colors are similar, that the general cohesion is good between the two. The company Black Box Infinite recently did a demonstration with the new Apple CarPlay designer to create 7 complete dashboard displays that were designed based on quite iconic dashboards. There was the NSX, the DeLorean, the Ferrari Testarossa, and a few others. I'll put a link to it below if you want to go check it out. But what they did was take those original analog gauges and redesign them in a digital format, so they felt both cohesive with the original car and the rest of the car, but more modern in their format. And it's a really, really nice look at the Apple CarPlay builder. So yeah, definitely one worth looking at. And it's a really good source of inspiration if you're thinking about doing that kind of redesign for your own car, but don't really know where to get started with it. So you've designed your user experience design, you've got your visual display, and you know roughly how it's going to look. Now we need to make the things. So skill number 3 is embedded programming. Whether your choice of microcontroller is Arduino, ESP32, STM32, Raspberry Pi, whatever it might be, you're going to need to be able to sit down and write the code that does the thing that shows the thing that you want to show. And it's going to need to take the information from all of the inputs, whether that's the CAN bus or ADCs and analog sensors, and process it in an efficient way and display it on your screens. On this channel, when we teach this stuff, we tend to focus, at least for now, on Arduino, well, ESP32 more specifically, because I really like the extra functionality you get in ESP32 as opposed to just like a standard Arduino chip. And pretty much all of the coding can be done in C++, which isn't the most complex programming language if you want to pick that up as a first one to go and look at. That being said, like all programming languages, you can program well and you can program poorly. And there's a bunch of criteria that I look for when I'm reviewing my own code to say, is this any good? Is it functional? Obviously. But is it readable? Can somebody else look at my GitHub repo and go, I understand what that does? Is it well documented? Is part of the same part of that process? Is it minimal and reusable? Have I created functions that I can just like ping values into and get responses out? Or do I have to rewrite large swathes of the code in order to fulfill that need? Are the overheads minimal? We've already looked at things like LVGL and some of the problems that we have when utilizing that with ESP now. And there are obviously considerations that we have to have when writing good code to make sure that those processes are kept as minimal as possible, because these microcontrollers, they're not stupidly powerful. We can't just throw unlimited processing power and memory at a problem until it goes away. We have to think about it in a more intelligent way than that, and actually make sure that the code that we write is purposeful and minimal. Once we've done with all of the artistic side of things, we're going to have to start to think about, well, where is this thing going to live? Maybe it's in a car, maybe it's in a boat, maybe it's on an electric bicycle. Whichever one it is, it's going to have its own needs from a hardware perspective. So that brings us on to point 4, hardware design, or I guess electrical engineering. If you're running your entire system in a house and you know that it's going to be run only off a USB that's plugged into a wall, and you can guarantee you've got a simple 5-volt circuit at all times, things like your circuit protection considerations can be a lot less complex than if you're trying to wire this thing up to a car battery, which has an incredibly dirty, incredibly noisy 14.5-volt system, which is constantly changing and very, very prone to spikes and fluctuations and transients. So in each one of those situations, you're going to need to know what hardware to put around your visual display unit, your VDU, in order to allow it to exist in the place where it's going to exist. It might be circuit protection, it might be voltage regulation, it might be something to do with sensors and the way that information comes into the system. But ultimately, what we're always trying to do is ensure that wherever our final product lives, it's safe, and it's not going to fail or cause the failure of other things around it. That's always, safety is always the number one most important thing of anything that you could create, especially when you're putting things into cars, which are like 1.5 tons plus of 100-mile-an-hour metal. Once you've decided where your thing is going to exist and what protections it needs and all the things around it in the circuit, there's a fair chance, especially if you're taking things to market or you want to create things in a more professional way, that you're going to need to utilize number 5, PCB design. Good PCB design, I think, is probably the largest of these 6 sections and probably has the largest amount of ways to go wrong. If you get a font wrong, so be it, you change it. And code, unless you're doing something incredibly stupid, is either just going to run or it's not going to run. They're generally the 2 situations. Poorly designed custom PCB can quite easily, as soon as you connect it up to a circuit, blow itself up. Or even worse, blow up other things around it. There are considerations about the good schematic design, about good component choice, which comes under those electrical engineering decisions we've just spoken about. There's the physical way that the components have to be laid out on a PCB, both so that they work and so that they can be contained within the space requirements that you have. You have to have considerations for noise. You have to have considerations for temperature. You have to have considerations for movement. There are tons and tons of variables when it comes to doing good PCB design. And it's honestly one of the things that I am most excited to learn more about as I continue this journey into productionizing some of these things that I'm making for myself. It's why I love partnering with companies like PCB, who supply all of the boards for this channel and are a fantastic supporter of the work that I'm doing here. At least I know that the manufacturing side is going to be absolutely perfect, because everything that they've provided for me so far has been absolutely perfect and works exactly as I wanted it to. So as always, thank you so much to PCB for continuing to sponsor this channel. If you use the link in my description, you can get $5 off your first purchase from PCB, and their first set of boards are only $5 anyway, so you're effectively getting them for free. And when we're done designing our PCBs and we've designed our screens and we've got everything, we need to put it in the car or wherever it is somehow, which leads me on to point number 6, the final one, which is 3D modeling and printing. I'm going to keep printing as it's a subsect of 3D modeling. 3D printing is its own big thing in itself, but for the sake of this conversation, let's just keep it as part of 3D modeling. When you finish a gauge, you're unlikely just to pop it on top of your dashboard, or, you know, drill a hole in your dash and try and stick it in there, you're going to want it to live somewhere, whether that's a pod gauge that works perfectly for your car, or whether you're replacing, like I am in my 350Z, the OEM placement of where they're going to go and reutilizing those slots. You're going to need to know either how to create something additive, so something that sits on top of something that already exists, like a pod gauge, or potentially how to reverse engineer existing slots of your car. For example, we did a previous video where I reverse engineered with some rapid prototyping the spots in my 350Z where my gauges are going to go, so that I could make 3D printed enclosures that perfectly fit in the OEM spots. It's not necessarily hugely difficult, but it can sometimes be time consuming, and I do realize that a lot of 3D modeling packages, especially Fusion, which is the one that I favor, can come across quite daunting, and it does have quite a large skill curve. It's not as bad as Blender, which has got the craziest skill curve of anything that I've ever used before. It goes from being basic, simple, to horribly complex in like an instant. Fusion, at least you can start in a 2-dimensional way, and then give things breadth and depth, and then, you know, adjust from there. But we are going to be making some more videos going forwards about utilizing Fusion 360, as well as 3D scanners and all that kind of stuff, so you can create things that work in your car and just fit perfect and just feel like they're in the right spot. In fact, the very first modification that I made for a car was I had a bug-eye Subaru Impreza, and it's really common that people buy these 3-gauge pods that replace the stereo at the top of the dashboard. But all of the designs that I could find when I had one were like what are called big wave, so they're like these really over the top, super audacious, Fast and the Furious inspired pod gauges. So I designed a new one using 3D scanning and then Fusion 360 that I called the Scoop, which sat really low in the dashboard and was a lot more cohesive. It flowed with the original lines of the dash, as well as then being modeled off the iconic scoop off the front of the bonnet on the car. And I still think it's one of the nicest things that I created for a car, and it sold out instantly when I put them online. And it goes to show that people actually really do value having well-designed, cohesive, OEM feeling stuff and places to put things in their cars, especially cars that are notorious for being modified, like the Impreza or like my 350Z. And funnily enough, when I designed that Scoop pod gauge, I'm 5'9" and change, so I'm basically bang on average height. So I was able to see when I sat in the car, for my eye line, the gauges sat basically perfectly. I could see them, but I was producing something that anybody could put in their car. So I had to think, well, what about someone who's 6'4" or someone who's 5 foot? Can they also like see the gauges clearly in this recessed pod if they're sitting at a different height? And so it then comes back to user experience design and actually putting all of that stuff together and then retesting it at the end to see if it still continues to fulfill the needs that we set up at the start, as well as a new set of needs that have come about by where we place it. So those needs might be, are things readable? That gauge had to be adjusted forwards by 2 degrees, because if I tilted it back 2 degrees, you would get a reflection of the gauge on the windscreen. So there's these things that actually start to apply that you might not realize apply until actually you have to apply them, if that makes sense. You know, until you put the gauges in the car, you might not see the issues that putting the gauges in the car presents. Which is why user experience ends up looping throughout the entire process. It starts at the start, it ends at the end, and it's ongoing. So yeah, those are my 6 areas that I think you need to master in order to be really good at creating these gauge designs. We've got user experience design, or user-centered design if you prefer. The user interface design, what it actually looks like, what colors you're using, what fonts, etc. Your ability to do embedded programming and making sure that the code is functional and reusable and necessary. Hardware design, making sure you're choosing the right components and things for the purpose. PCB design, ensuring that it's suitable for the conditions of the thing that it's going to exist in, and 3D modeling and printing to create enclosures for this thing to exist. If you can get really good at all 6 of those things, you can create some fantastic products that I can guarantee you people are crying out for. That's why going forwards on this channel, we're going to be looking at those different 6 areas in various bits of detail. Now, like I said, I don't pretend to be an expert on all of these subject matters. There's some that I'm well versed in, some that I'm not. So where do I put my graph? What does it look like? And let's judge it from 0 to 5. 0 being never done it before, 5 being expert, absolute expert. You should definitely listen to me on this. User experience design. User experience design is probably the only time I'm going to give myself a 5, because I did my master's in user experience design for small screens. I did my PhD in user experience design for virtual and augmented reality. I created and then led the first user experience division for cybersecurity and counterintelligence for the UK intelligence community. The list goes on. If that doesn't put me at a 5, I don't know what does. So yeah, we'll start strong. User interface design is something I think is a little bit more subjective. It's like that old adage of, I don't know art, but I know what I like. I believe that I can create things that are aesthetic and, pretty to look at whilst fulfilling a purpose. I've ran design agencies in the past and spent at least 20 years of my career as a user interface designer and developer. So, I know what I'm doing in that front. Let's go for 4 on that one. I'm very good at it, but I'm sure there is more that I can go out and learn. Embedded engineering coding is an unusual one because I've spent over 20 odd years, like I say, as a developer. I know a lot of programming languages very, very, very well, but C++ that we use on this channel almost exclusively, I didn't start learning until the end of 2023. So I've only been doing it 18 months, give or take. There's definitely a lot more that I can learn about being a really good embedded engineer software programmer. But my knowledge about coding principles, how to make sure that we write things that are functional and useful and repeatable and, well documented, are very good. So I'm going to go in the middle. I'm going to go for a 3 because my programming is very good. My knowledge of general programming is very good, but specifically my C++ does have a bunch of holes in it that I don't know, and I often have to look things up. So there is definitely a lot there more to learn. The hardware design choice is probably my weakest one. At the moment, I tend to either rely on others to help me pick the right things or use a lot of off-the-shelf products, especially during prototyping. So for example, step down voltage regulators that you can just go and buy 10 of for £5 and utilize those in order to make sure that my circuit is protected. It works fine in a prototyping environment, but less so in a production environment. I still have a lot to learn about that. So I'm going to go for a 1. It's like I'm still a beginner in that department, and it's something we can learn together as we move this channel forwards. Similarly, PCB design is still something that is relatively new to me as well, and we have started bringing other people in on this channel like Matt Kaiser, who we created a video with about reviewing PCB designs, which has been incredibly useful for me to realize where I'm making mistakes in good PCB design. I've definitely got a lot better at it in the last 6 months in particular, but I am very aware how big it is, and I'm very aware how much there is to learn. So I would hesitate to give myself anything more than a 2. I'm not quite a beginner. I'm a bit better than a beginner, but I still have a long way to go. And finally, 3D modeling and printing. So a lot of people don't know that prior to actually starting this YouTube journey, I ran a 3D cosplay prop making business for 5 years. And still have all of those stores online. It keeps my life afloat. So I have designed a lot of things significantly more complex than I will ever require to put into a car. A car is going to be a gauge or a pod or something that's generally going to be pretty simple compared to incredibly intricate swords and daggers from Baldur's Gate 3, for example. I don't think there's a lot for me to learn in that field when it comes to, you know, creating this kind of stuff. I think this kind of stuff is much more simplistic than a lot of the stuff I've done in the past. So yeah, I have my skills. My UI, UX, and 3D modeling, very, very good. The hardware side of things, the PCB designs, the electrical engineering, and to some degrees the coding, still got a fair bit to learn, and that's fine. What that means is if you're subscribed to this channel and you're following along these journeys, those things that I'm very good at, you can listen to me as a voice of expertise. The other things you can learn with me, and we can go on that journey together, because I'm going to get myself up to 4s on those things. It's just going to take a bit of time. Doesn't happen overnight, and that's great, because that's the journey, and that's what we all get to, you know, enjoy together on YouTube. So I am a 543-125. 543-125. What would you judge yourself at? And anybody who puts 555, 555 can get out, because you're not, I guarantee it. You might be very good at a lot of the areas, but those people generally don't exist. So don't lie to yourself. Figure out where your weak points are and your strong points are. Being bad at something is not a bad thing. What is it Jake says? Sucking at something is the first step to being kind of good at something. I like that. Also, what areas are you interested the most in upskilling yourself at, if any? Are there certain elements or certain things that you want to learn? What would you like to see on this channel, if anything, related to this kind of stuff? Let me know in the comments, and we'll see what kind of videos we can make on it going forwards. Also, do you agree with this list? Do you think these are the 6 main points? Or do you think there's other stuff that we could also add in there that's really important that I've forgotten? Again, let me know in the comments what you think. Anyway, I need to go and get over being sick, and also put my car back together, because if I look around me here, most of the exterior of my car is currently in my workshop being rewrapped, and it's taking forever. And so I need to get that out and on the car. So let's get that done, and then next week we'll be back with some proper content, actually doing some proper stuff, rather than me just sitting and talking at you for 30 minutes. Whatever you do with the rest of your day, folks, stay well, have a wicked one, and I'll see you in the next video Wednesday at 2 p.m. Take it easy, peeps. Bye-bye.